Okay. Let's do this. All right, so we're beyond the midterm exam. We had, I don't want to spend too much time talking about the midterm. We had some issues there with slowdown with the app that we gotta definitely have to address. Um, I think my concessions for the midterm by having the AOs uh, basically count double, so you just had to get one of each type of quiz. I think that's more than enough concession with the 15 extra minutes, and then you really only had to do two of the four. Uh, I think that more than took care of the issues, and I base that on the results. Like, the results are far better than most semesters. Usually, for a midterm in this situation, usually about half the class would do well on it, and it's more like 2/3 to 3/4 of the class don't have to take the final after 2/3 of the class doesn't have to take the final after that. So I think the concessions more than made up for the slowdowns. So that's really all I need to say about the midterm. The performance was pretty well, aside from the performance being better because of the consolations, the way the AOs were calculated. Y'all still did better than a lot of other semesters on that, so I'm happy to see that things are looking good with that. In terms of tests, we're past the test 4 deadline. Most of y'all aren't worried about the final deadlines. At this point, you're hitting the expected deadlines surprisingly well, so I'm happy about that too. The semester's going pretty smooth. I don't want to get too optimistic before we hit the end. I'll hold my breath until the final results are in, but things are on track overall, looking at the whole picture. And today we're doing polymorphism. This is lecture 9 out of 10. After today, we'll be 90% done with lecture content. And then Thursday, just 2 days from now, we'll be 100% done with all of the lecture content. Everything will be in your hands. Most of you don't have to take the final exam, which is fun to hear. So after Thursday's lecture, that's all the content. It's wrapping up the 8 tasks, and then that's it. That's CSE116. So I said it very often that the semester goes by fast, and I'm ready for it to go by fast, and it still takes me off guard how fast the summer semester goes. It's like we're already at the end of it here. Pretty wild. So test 7, this is what we want to prep you for today. By the end of today, you should be able to do test 7, understand all of this stuff in here. So let's talk about what test 7 is and what you'll be doing. You'll be creating the media library class. This media library class is going to store songs and movies and do just a little calculation on them. So let's break this down. There's only three parts to this, if you can count the constructor as a part. So the constructor takes no parameters and doesn't do anything. This is the default constructor, so if you don't even write a constructor for this class, you already have that box checked. So you have 1/3 of the things, one of the 3 things done already. So I don't know if I count the constructor as part of this. Next is a populate library method. Populate library is going to take advantage of everything you've written in task 6. So task 6, you wrote those 3 methods to read files of 3 different types. This method is going to take 3 strings that are 3 files in those 3 formats, and the intent is that you'll just call the 3 methods that you wrote in task 6 and let those methods do their work. You already wrote those, tested them, submitted to Autolab, made sure they were good and everything. Let's use those 3 methods and get some of the payoff of what we've set up in task 6. And as you'll see throughout doing tasks 7 and 8, this is where we get a lot of the payoffs from the setups we've had in previous tasks. So we're going to see a lot of the previous stuff all come together to accomplish the goals of these last 2, especially this one. Task 7, more so than task 8, really combines a lot of the previous tasks to get its job done. So task 6 directly, you're calling task 6 here. The intent is that you take these 3 strings, the 3 file names, call read songs. That gives you all your songs with ratings and everything. That's just a one method. Then you call read movies on the movies file, and then the output of read movies, you feed that into the input of read movie ratings along with that third file name with the movie ratings, and that'll return all of your movies with all the data. And the way we set this up in task 6, that last read movie ratings method call, the movies that it returns will all be complete. They'll all have complete information, meaning that every movie that's returned in that array list will have a title, cast, and at least one rating. That's why we had those situations, those edge cases in task 6, where if there's a movie that's rated that wasn't in the input array list, you shouldn't return it because it doesn't have cast. And if it's in the input array list but not in the movie ratings file, if there's no ratings for it, don't return it. That's because we don't want any movies that don't have any ratings. So when we're done calling those 3 methods, every song and every movie we have, all of them will have at least one rating, which will be important for our next method. Everything's going to have at least one rating. That's why we set things up the way we did in task 6, specifically with the read movie ratings method. And then, so this one, you're just calling your other 3 methods. You don't have to do too much in the populate library method. And then top K ratables is the one that's going to do more work for us. This is going to take an int and give us a top K list, where K is the int that is taken as a parameter. For example, if you call top K ratables of 10, this should give you a top 10 list. If you give, say, top K ratables of 1, that's going to give you the top 1 result. So whatever the input is, that's what K is, and give me a top K list. And that's going to give you the top K things, either movies or songs, based on their Bayesian average rating with 2 extra ratings of value 3. And it's going to return those whether they're songs or movies. So we're mixing, this is the big new thing for the homework, we're mixing songs and movies in the same class, the same media library. So we have not just songs, not just movies, but movies and songs all mixed together. And that's what we want to learn today. We're going to accomplish that through polymorphism. So everything's coded to the rateable class. And since movie and song both extend rateable, we can get away with mixing them together in as long as we're writing our code to handle any ratables. So populate library, by the time you're done with this method, you should have all your songs and movies in a single data structure of type rateable. And then top K ratables goes to that data structure, sorts it based on Bayesian average, and then in decreasing order, and then returns the top K values from that sorted order. So there is a situation here where you're going to have to sort those values based on some custom sorting criteria. We've seen multiple ways of sorting in the class, so any way you want to sort, I leave this intentionally undefined as to how you should accomplish that. But you have a situation where you need to sort based on some custom way to sort. So it's up to you to grab whatever tool you want to do that, which I'll pretty much give away here. Is we saw the insertion sort method. I gave you the insertion sort method in lecture. You can grab that. You coded BST. My favorite option would be use the BST that you wrote in task 5. We already wrote custom sorting code in a previous task. The BST, you have to provide it a comparator. So you would need a new comparator, or for the insertion sort method, you'd have to write a new comparator and then let the code that already exists do all the actual work for you. So you write the comparator, which needs to work with ratables, but it's the Bayesian average comparator that you wrote for songs. So take your song Bayesian average comparator, copy that class, and instead of song, put ratable. You have your comparator, you already have your sorting code, you're done. If you are using BST, you do have the case where you have to convert that linked list to an array list. So you do have an extra step there if you're going that route. But take advantage of the comparators, this whole comparator setup that you've already built to sort your ratables. And that's really it. for simplicity's sake, don't make any two songs or movies have the same Bayesian average, and don't make them have the same title either. None of my tests will have those features. None of my tests have two songs or movies that have the same title or the same Bayesian average rating. So we don't have to worry about those edge cases. At this point, that stuff starts to get a little tedious. I've had you check relative orders, where the orders don't matter. I did that. We did that in the last task, and I don't have to keep hitting you over the head with it. And when Bayesian average ratings are the same, they're not actually going to be the same depending on how the truncation errors all roll out. They might end up being the same, they might not. So let's just avoid that situation entirely at this point. And the testing utility method, comparing ratables, for this, you only have to check if the... wait, that's not true here. When you're testing the top K ratables, check to see if the ratables have the same title. As long as they have the same title, we can call them the same. We could check the ratings as well, but at least check the title. You don't have to check the song ID, the song artist, or the movie cast list, because we won't have access to them because they'll be ratables. We won't know if it's a song or a movie. And this one I want to highlight. This testing utility method is a lot easier than the one you've written for task 6. The only way to really get in trouble with this one is overthinking it. Don't overthink this one. It's easier than what you've done in the past. Just knock it out and be done with it. Because these will be in the same order, and we're only checking the titles of the ratables. So much, much simpler than what you've just done, where you were checking to see if it had the same movies in any order, and you had to check all of the values of the movies, the title, the cast, and the ratings. So this one is significantly easier than what you've just done. Don't overthink it. It's not meant to be difficult. It's just meant to be used to check the output of your top K ratables method, so you can set up your expected and then stuff it in your utility method. And overall, I think this task is a step down in difficulty from the previous two tasks. I always have the time estimates. I don't always highlight them like this, but the time estimate is my estimate of how long it should take. And this does go down from task 6, I said 7 hours. Task 5, 6 hours, which task 5 maybe should be the 7, and maybe task 6 should be the 6. I mean, they are estimates, so just my guesses. But task 7, I think, is definitely easier than the previous two. Some of you will disagree, because some of you will run into very specific bugs in task 7 that make task 7 more difficult, that maybe you just, the stars aligned and you coded task 6 up once, and it was just right out the gate, you had it perfect. So, there will be certain circumstances like that. But on average, across the whole class, across all of you, task 7 is going to be easier than the previous two. Which is fine. I'm fine having some easier tests at the end of the semester. I don't believe that courses need to be always increasing in difficulty as the semester goes on. We can have more interesting difficulty curves, and that's okay. All right. I guess we're ready to jump in. Yeah, I think that's it. I'm gonna delete this. I'm gonna delete all of this. Just to clean things up a little bit. And go into the code. I shouldn't have to go into any slides at all today. I don't intend to. We're going to do everything right in IntelliJ today. And today it is the there's a bit of wiggle room in today's lecture. Like the stuff that I absolutely have to cover isn't going to take the entire time. So if you do have questions, even if you have questions about the tasks or questions about the concepts, anything, I'm fine getting off track today. And if I have something that I want to show while I'm going through the code, I might myself just get sidetracked on something that I want to talk about. Anything that comes up as we're coding, anything that comes up naturally. So if you have questions, more so than most lectures, this is the lecture to ask. And especially like last lecture was really rushed, talking about reading files, since we lost so much time to the midterm. So if anything there you want me to go revisit and talk about again, I'd be absolutely happy to do that. So let me make sure my code still compiles. And if there are no questions, you're leaving me to my own devices, and I'll just cover whatever I feel like covering. And I do want to make a little bit of change here. I don't like having player extend game item, so I'm going to get rid of that. But other than that, this is mostly the code that we've seen at the end of inheritance. So we're talking about polymorphism today, but I want to start by refreshing what inheritance is, because you cannot have polymorphism without inheritance. You need inheritance. That's the foundation. And then polymorphism is one of the payoffs of setting up inheritance. That's something that we get to do because of inheritance. So I want to spend a little bit of time refreshing what inheritance is and just revisiting our example with game items, health potions, and weapons. And the player class, we're going to get the player class in here, which we didn't fully do in inheritance. So let's just get up to speed on what the code is again. So game item was a class that had X location, Y location, a constructor to set those, a move method, our getters and setters, and a use method that I'm going to actually delete this one. This is the one that we saw in lecture, but I want to switch this to use that takes a player reference. So this is not just using an item in a vacuum. This player is using this item. So now we have access to the player that's using the item, so we can do things like, I gotta rewrite this one again. I rewrote it in the other lecture, but I went back to the starting point for this one. I'm blaming Paul for this one. To heal a player, he said you're going to take negative damage. I don't know why he set it up like that. It bugs the crap out of me. What's up, Ming? And we're going to fix this. That might be the first thing that we do, actually. Let me get my override annotation also. This is where we had... Caps lock is on. This is where I was sometimes using annotation, sometimes not, just to show the difference. Like, it is optional talking about that. I want my override annotations now that we're actually in here coding. So the use method, I don't like this. The player taking negative damage. And actually I have to go to the player class because we don't have all of our getters and setters. So I'm actually going to delete our getters and setters and then ask IntelliJ to kindly create our getters and setters for us. So now we have all getters and all setters. So I have access to everything. But let me back up 1 second. The game item class has the use method. And then in health potion, I'm going to override the use method, so replace it with my own definition, and let's write this in a way that makes sense. Player dot set HP equal to the min of the player's max HP and the player's current HP plus this dot increase. So we're going to heal the player by the amount of increase for this potion unless that exceeds their maximum HP. So they're not going to be able to heal more than their max HP. Much more robust than taking negative damage, which just subtracts from HP, and subtracting a negative is going to add with no cap for max HP. We don't want to roll like that. Okay, so health potion extends game item and overrides that use method, calls the superclass constructor. I was very happy to see that just about all of you had your superclass constructor calls on the midterm. very, very good to see that. So repeating it so many times in lecture, it's what I got to do to make sure very few of you make that mistake. And those of you who did make the mistake, I have to assume one of two things. Either it was just a simple mistake and you forgot in the moment because it was stressful, and then the things were taking too long to load and it was just too much, and it just slipped your mind. Either that, or those students just don't watch lecture. I mean, it happens. It's sad, but it happens. It's sad when they fail, I should say. I don't care if you don't watch lecture, but you also crush everything. I actually don't care. But if you don't watch lecture, and I mean, you're not hearing my voice right now anyway. You're never going to hear me say this, so it doesn't matter what I say. But if you don't watch lecture and fail, I don't understand what those students expect, especially when they email me after they fail and they're like, try to make it my problem and my fault. You didn't watch lecture. When I told you exactly how to do everything. Okay, not ranting, not going down that path. So we override the use method. We have a health potion specific method. This get increase only exists for health potions. It only makes sense for health potions because they have the increase variable. Then we have an overridden toString. I'm going to rewrite this a little bit. We have it stored in a variable, but that's only for memory diagram purposes. We don't need to do that here. Where we're calling the super toString and then adding extra functionality to it. And then a main method, which we're not going to use. Weapon also extends game item. Weapon has damage for some weapon specific behavior. We're not going to do the use method that doesn't take any parameters. We want the one that is being used by a player, and we're going to set their damage to the damage of this weapon when the use method is called, when a player uses a weapon. This is simulating equipping the weapon. The player is going to now be equipping this weapon, so whatever the damage output of the weapon is, that's now the damage output of the player. We have a toString method. Let's simplify this one as well. And this is the main method that I do want to use. We're going to expand it and work with this a little bit more as we go. Actually, we can leave that. But we'll expand this as we go. And then the player class, we have max HP damage dealt. Constructor is just going to take max HP. They have default damage dealt of 4. This is one mistake that I did see a lot, but every lecture example that I have, pretty much all of them, the constructor will take all of the parameters that match the instance variables. But then in OOP2, one of the most common mistakes, there would be something like this, where the constructor only takes max HP, and the stack frames for the player constructor, a lot of y'all would have HP and damage dealt in that stack frame, even though it doesn't take those parameters. Those don't exist. So that's one of the things I called it a minor error and said, you know what, it's fine, whatever. But that's not how it happens. This is just like any other method call. Max HP and damage dealt would not be in the player constructor stack frame. It's whatever the parameters are and any local variables that are declared, but not the instance variables. Instance variables are not automatically in the constructor stack frame. That was very, very common in OP2. The truck constructor did not take a load variable. The car constructor did not take a weight variable. So those did not exist in those stack frames. So damage dealt and HP would not exist in the stack frame, but they do exist in the player object that's created because they're instance variables. Our getters and setters. A toString method, which I want to change a little bit. Let's make this a little simpler. And just return health is our current HP over max HP. Can I change this to, I'm going to use refactor, and I'll inevitably end up showing a few things like this today, so let me talk about it right now. we're at the point in the semester, and actually we've been at the point in the semester where when I'm doing live coding, I want to show more like tips and tricks and little things that aren't necessarily related to the concepts, but things that'll help you just be better coders and just neat things that you can do while you're coding. Refactor, I've already shown this before in lecture, so this one isn't brand new, but I'm going to do refactor and rename, and then I'm going to rename this variable to, oh, well, I messed it all up, so I'm not going to do it. Refactor, rename, and then I'm going to name this lowercase hp. It never should have been uppercase hp. I guess it's a little debatable in this case, but I'm going to name it lowercase hp because uppercase hp makes it look like it's supposed to be a constant. So lowercase hp, and then that's going to change it everywhere in the code. So I don't have to go through everywhere and change that variable name. It's changed everywhere just by changing it once. So refactor does. It looks for everywhere that that's used. It even changed my parameters to lowercase hp when it was being assigned. Okay, so that's toString. I want my override annotation because I'm no longer making the point that it's optional. Let's add that in. Take damage is going to subtract HP. And then attacking another player, which isn't something I'm going to use in the in this example, but that's combining a few things that we saw. Take damage, and then using this player's damage dealt parameter, which is going to be increased if they're equipping a weapon. And then this main method I'm not going to use either. So this is pretty much, for the most part at least, where we left off in inheritance. And now let's talk about polymorphism. So when a weapon extends game item, or when any class extends another class, this is a very special relationship that we call an is-a relationship. So a weapon extends game item, which means it gets all of the state and behavior of the game item class. Let's try to organize this a little bit. So that means weapon is going to get all of the state and behavior of the game item class. So weapon has an instance variable damage and also inherits instance variables X location and Y location, which is something a mistake I saw in the midterm a little bit, not too much, but a good handful of students made the mistake. The weapon will get its own instance variable and the instance variables from the superclass. A few students made that mistake, which is absolute fundamental mistake. That's a major error. That's instant fail. If you don't have, if you don't know that it inherits the state and behavior, very fundamental. So weapon gets damage and X location, Y location is its instance variables. It inherits all of the methods from the game item class. And also game item implicitly extends the object class. So game item gets all the state and behavior of the object class, but also weapon gets all the state and behavior from the object class. So weapon extends game item, which extends object, which means weapon indirectly extends object. So every class in Java is going to have an inheritance chain that ends with the object class one way or another. It's going to get there. It either extends something directly, which might extend something directly, which might extend something directly, which extends object either explicitly like this, but we never write that. We would do it like this implicitly. So game item extends object. Eventually you're going to get to a class that you extend that doesn't extend another class, and that class extends object. So you eventually get to object. So weapon extends game item, and also weapon extends object. So weapon has all of the state and behavior of all three of these classes: weapon, game item, and object. And this is a relationship. In a very real sense, a weapon is a game item. Since it extends it, it is a game item. Another way of thinking of this is when we write the weapon class, we're going to start with the game item class and then extend its functionality in the weapon class. We're going to add some weapon-specific behavior to the game item class, and that's how we develop our weapon class, is by starting with game item as our base and then building on top of that. So it is a game item, but it also has some extra stuff. some extra functionality inside of it. By the same token, weapon is an object because it is in its inheritance chain. So any object in that inheritance chain for a class, it is all of those types. A weapon, when I create a new weapon, that weapon is... No, I am going to delete this. This weapon is a weapon, it is a game item, and it is an object. Now, why does that matter, though? Like, what does that actually mean? Oh, and by the way, the is a relationship. You should be familiar with this from geometry. The whole square is a rectangle, but a rectangle isn't a square. But all squares are rectangles. That's kind of the same relationship here. It has all of the properties of a rectangle, but it also has some extra properties. A weapon has all the properties of a game item, but it also has some extra properties. So it is a game item. And I guess to extend that analogy, the object class would be like the shape class. Every shape is a shape, a triangle, rectangle, circle, whatever. They're all shapes in a very real sense. And that's polymorphism. Polymorphism, the poly, I'll type it out even. Poly is many, morph, form, polymorphism, many forms. So the weapon class, any object of type weapon, has 3 different forms. It's a weapon, it's a game item, and it's an object. Where this matters in our code is right here. If I create a game item variable, I can assign it a weapon object. And this is polymorphism. If an object is of a certain type, it can be stored in variables of that type. Since a weapon is a game item, weapon objects can be stored in variables of type game item. This is where we're going to start seeing the lines get blurred a little bit of... Let me try to get all this on screen. This is where we see the lines get blurred a little bit of the strong typing. Right from day one of Java, I say a variable of type double can only ever store a double, which is still true. A variable of type game item can only ever store a game item. But a weapon is a game item. It's not directly a game item, but it does extend game item. Like, it still is a game item through this inheritance relationship. So we can store a weapon in a variable of type game item, and as soon as we have this assignment where the types don't match exactly 1-to-1, but game item is somewhere in the inheritance chain of weapon, that's polymorphism. That's when we're leveraging polymorphism to do something that we normally wouldn't be able to do, this mixing types of variables and values. And we can go one step further. Object weapon3 equals new weapon. This is also valid. All 3 of these assignments are valid. The compiler's not yelling at me, Java's happy, IntelliJ's happy. Everything's great here. This is valid code. In fact, variables of type object can store whatever you want. Any object ever. Every object has to either directly or indirectly extend object. So variables of type object can store any object ever. Any one of them. It's usually a bad idea to do that, but you can do it. And this is polymorphism. This is really it. Let's make these consistent. Let's make them all 20. But why would we ever want to do this? That's what we have to spend a bit of time talking about. Why would we ever want to do this? And before I even tell you why, I think polymorphism is super powerful. It's super a very strong thing that you can do in your programming. So much so that I'm going to start with its biggest weakness. There's one big big downside to polymorphism, to storing these objects in variables that don't match their type. So if we do weapon 1, for example, we can call, we're in the weapon class. That's exactly the way I want this set up. But I'm going to stick with it. Public int get damage, return this dot damage. So we can call get damage. That's a method that I wrote in the weapon class. So when I say get damage on weapon 1, that's going to return 20. It's going to do exactly what I expect it to do. I auto formatted and got rid of my, oops. I'll get this all on screen. This is perfectly valid. Nothing new here. We have a variable that matches the object type, and we can call a method on that object. Okay, great. We would expect that without knowing inheritance or polymorphism. That's perfectly fine. Where we start to see some differences, and we see the biggest downside of polymorphism, is when I try to call a method, the methods that I can call are only the methods that are known to the variable type. So since weapon 2 is of type game item, I can only call methods known to the game item class, which does not include get damage. Get damage is weapon specific. I wrote that in the weapon class. So I can't call, actually I'm going to get rid of this toString method just for space considerations. I'm going to keep that one. But the game item class doesn't know about a get damage method. So this doesn't compile. I can't run this code. It's not going to work because that method is not known to the variable type. Weapon 2 is of type game item. Game item cannot find a get damage method. And same thing if we go one step further, weapon 3 dot get damage. The object class certainly doesn't know about some get damage method. Doesn't exist. Doesn't know about it. This doesn't work. This doesn't compile. Nothing works here. So the methods that can be called are only the methods known to the variable type. Now if I want to change this to, I am going to need that player back. Player equals new player. No, player only takes max HP. And I misspelled it. So if we change this to use of player, yeah. I'm like, why am I getting an error there? Let's not print to the screen. So if we change this to use of player, I can call use of player from weapon 1 because weapon has a use method. Even if I delete this, weapon 1 of type weapon knows of the use method because it inherits it from game item. Game item has a use method. It doesn't do anything in this case. It has a use method that takes a player. So that's a valid call. Weapon inherits this method. So we're allowed to call it. That's perfectly fine. I do want my overridden method though, so I'm going to put it back. So it definitely has a use method, but also the game item class does know about the use method. It has a use method, so this is a valid method call from weapon 2. But from weapon 3, from the object class does not know about this use method, so this one does not compile because the object class has no idea that this method exists. In fact, the ISA relationships, then inheritance is strictly one way. So weapon extends game item. Weapon is a game item. Weapon gets all the state and behavior of game item. But game item doesn't even know weapon exists. Nowhere in the game item class does the word weapon ever appear. It doesn't know about the weapon class at all. It doesn't get notified when it's extended by another class. It just doesn't know weapon exists in any way, shape, or form. So from the game item class, we can't use weapon-specific state and behavior because it doesn't know about it. The game item class doesn't know about it. The object class in Java doesn't know about any of our code at all. It only knows about Java itself. And it really doesn't know much about Java. The object class knows about the object class and doesn't know any other class exists except classes that it uses within its own definition, which I don't know if there are any. Class, int as a primitive, object. Oh, it does know about clone not supported exception. String. Okay, that's fair. It has to know string. And that's about it. I mean, we might find a few more exceptions at least. We might find a few other ones, but like the object class doesn't know much. There's not much there. Definitely doesn't know about our use method that takes a reference to a player class that we also wrote. Doesn't know about it, so this doesn't compile. We can call toString on all three of these. This is valid because the object class knows about the toString method. So that's valid too. What? How did I... Fourth time's a charm. We got there. Does not compile. Can't do that one because object does not know about this method. Doesn't know about it. Okay, let's get game item off. Let's get our things centered a little better. Let's do this. And so we can't make this call. Doesn't compile. Doesn't work. Doesn't work like that. So the variable type determines whether or not a method call is allowed. And that's really its only job. It's going to check, is this method call allowed? It has nothing to do with what method is called if the method call is allowed. And to show that, I'm going to jump into the debugger. So it doesn't determine what method is actually called. So the method that's called is still, as it was all semester, it's still going to depend on the type of the object that's calling the method. So when I call this code, I'm going to set my breakpoint and then run the debugger. That's going to stop my code at this breakpoint. And we should have time for a good debugger, I guess refresher or tips and tricks or whatever you want to call it at the end of the lecture. We did in the other lecture today. But I'll get a little bit in right now. So when I call the use method on this weapon, weapon 1 is of type weapon. So the variable type just checks if this is a valid call. The weapon class knows about the use method. So that's perfectly fine. When the method is actually called, and by the way, weapon 1, weapon 2, weapon 3, these all store references to weapon objects still. They're all still references to weapons. They all still have their full array of instance variables, meaning all three of them have a damage instance variable. They're all the same exact thing. They just happen to be stored in variables of different types. But the variable storing the object has no effect on the object itself. It just restricts what methods can be called through that variable. So weapon1.use of player, once we finally call the method, we don't care at all what the type of the variable is anymore. The variable check is going to happen at compile time to see if the method call is allowed. If we're running the code, that means we're already past compile time, and we no longer care about any of the types of any of our variables. So now when we call this method, we check the type of the calling object. The calling object is of type weapon. So we end up in the weapon class, and we look for a method named use. We find it right here, and this is the method that's called, the one that's going to set the player's damage. If we step into, we'll get into the set damage dealt method. That's going to change the player's damage dealt. So this player, their damage dealt is now 20, and that method call ends. Now from weapon 2 of type game item knows about a use method. Game item knows about a use method. It doesn't do anything, but it knows that the use method exists. It takes a player, it returns void, it knows about this method. When we call the method, we still don't care about the variable type. That just determines if this line of code compiles. It does compile, but now when it's called on weapon 2, which is a reference to an object of type weapon. So we still do the same thing we've always done all semester. The method is called through an object of type weapon. So we look in the weapon class, and we look for a method matching the signature that was called, the use method that takes a player, and it's the weapons use method that's called. And this is very important to know. The weapons use method is going to be called even though this method was called through a variable of type game item. The variable only determines if the method call is allowed. It's the object type that determines which method is actually called. So it's going to be the weapons use method that's still called in this case because the object is of type weapon. We get the damage dealt. It was already set to 20. I should use different numbers there. But we're going to change the player's damage dealt to whatever this weapon is. So this weapon's use method was still called. We did not get the game item's use method that does nothing, even though the variable was of type game item. Do not look for the variable name, the variable type for which method is called. It's always the object type. Same thing we've done all semester. In your memory diagrams, you find the calling object, you look at the type of that object, you look in that class for the method that's being called. Same thing. It's the reason that I did it in that very specific way right from the first method that was called. I did it in that very specific way because it's the same thing, whether it's just regular objects, objects with inheritance, objects using polymorphism. It's all the same thing. The type of the object determines the method that's called. And if we don't find the method in the weapon class, then we go through our progressions just like we always had. If we don't find the use method here, we look in the superclass, but only if the object class, the weapon class in this case, doesn't have that method would we ever look in game item. We don't start the search in game item because of the variable type, which is a common mistake, a common thought that you might think, well, weapon 2 is a game item, so I have to look in the game item class for the method. It's not the case. It goes by the type of the object being stored in that variable. And then that's the end of the program. Great, right? Okay. Polymorphism, we can store our variables in we can store our objects in variables that are of any of its supertypes, but why the hell would we ever do this? The only thing it did was restrict what we can do with that object. Like this weapon 3 is still an object of type weapon, but I can't really do anything with it. I can convert it to a string. Yay. Yippee. That's not very helpful. So all polymorphism does so far is hurt us. It just restricts our behavior. So why would we do this? And the short answer is we would never really do this. There are some specific situations where I would do this, where I would have my variables not match my my object types for very kind of specific, obscure reasons that you might run into, eventually. But really, never a good reason to do this. So why do we care? Like, why do we want to know polymorphism? And it's because it can make other classes simpler. So let's jump over to the player class for a bit. And see how we would write this class. And IntelliJ keeps collapsing my parentheses, and I don't like it. I don't like that. And the reason is to make other classes simpler. So let's go up above our getters and setters here. So now players want to start using objects of our types of health potion and weapon. So I'm going to write methods to do that. They can return void, and I'm going to need a method use weapon, which is going to take a weapon. I'm going to call it weapon. And it's going to do weapon. All it has to do is call the weapons use method, because the player doesn't need to know what every single item type does. It's just going to call its use method, pass a reference to itself, because this is the player that's using the weapon. And then the weapons use method has a reference to that player that's using the weapon and can modify that player in whatever way it needs to do to get the job done. So we need a use weapon, void use health potion, health potion, whoa, not that, potion dot use of this, which isn't terrible. Oh, hey, I get to talk about this. This happened in the other lecture. Actually, I had to intentionally do it in the other lecture. I'm glad this happened by mistake this time, but I still get to make the same point. So we'll put the conversation of why polymorphism on hold just for a second. So when I did health potion, I wasn't very careful about how I did this, and IntelliJ auto imported week 7.health potion for me, even though there's a health potion in this package, in the package that I'm working in right now, and that's the one that I want to use. I got an auto import week 7.health potion, which broke my code because week 7.health potion doesn't have a use method that takes a reference to a player. Oh, it actually does. Wait, why didn't that work? Oh, because this player is going to be a different player. This player is the week 7 player, which is not the player that I gave it. I gave it a week 11 starting point player. So I gave it the wrong type of player. But sometimes when you have classes that are the same names as other classes, the auto import is going to get you in trouble more often than not. The solution to this is just deleting the import, and now everything works, which seems really weird if you don't see exactly what's happening there. But without the import, now health potion is going to be the health potion in this package, because classes in the same package don't need to be imported, and now everything just works great. The one time this comes up in your homework, which we're all past this anyway, but the one time this comes up in your homework is with the comparator class. It's the one class that does share a name with a built-in Java class. There is a built-in Java comparator class. So if you do import, actually this is a bit of a side thing, but worth mentioning at least. Import Java. So this is the insertion sort code. If I do import java.util.comparator and import Java's comparator, none of the code works. The only issue was this import statement, because if you're not careful and you're letting the IDE do too much for you without understanding what it's doing, it's going to slap this import statement on here, break all of your code in a really strange way, because the insertion sort class, like everything here is perfect. Like nothing's wrong here. The problem is that now this comparator is your Java util comparator and not the comparator that we've created for the course and for the homework. The one that's in your data structures package in your homework, that's the one you need to be importing and using. So if you have this import Java util comparator, that's going to get you in all kinds of trouble. That everything's messed up, because now this comparator is not the right comparator class. But if we get rid of the import, problem solved. Okay, and I need another, so this isn't too bad when it's just 2 objects. It's not too bad, and then you have to use your imagination. Well, if there's 100 of them, if there's 98 other ones. But since we're live coding and we got a little we can little time we can emphasize this a little bit more. Let's get at least a third item in here. So new, and I meant to ask y'all what item you want in this game, so I'm just gonna have to create something. We did rock in the other lecture. It was asked for in chat, but let's do gold bars. So gold bars, we're gonna extends game item. So we get all the game item location behavior. We're going to have public gold bars value. Let's do double value. Can we get more monetary value? Value is just so vague. Monetary value int x int y super of xy. This dot monetary value equals monetary value private double monetary value semicolon, and let's generate our getters and setters for monetary value because I don't feel like typing monetary value 2 more times. Okay, so we have another game item in our game. Player can pick up gold and probably sell them. Let's say public. Actually, no, I don't want to do that yet because I can make a good point later if I don't. And now we add a new game item. So we want to expand our game. We're creating this new game item, gold bars, and we have to go back to our player class. Every time we add a new item to our game, we have to go back to our player class and add a method for that, for use gold bars bars dot use this. And you might say that's still not that bad. It's just a one-line method that we're cut and pasting each time, because if I want a new item, I'm going to cut and paste this and change the types. It's not too bad. It's a one-liner. But what happens when you want to expand this one line? That's going to start getting a bit more tedious. Might still not be absolutely terrible. But where this really gets set off is what happens when you have your entire physics engine and your entire game engine, an entire game where every time you want to add a new item, you want to add the ability to... No, I want a new item type. You want to add grenades to your game. And I want to be able to lob those grenades in a nice parabolic arc and have them land in the right spot. My physics engine is going to take care of all that. And my physics engine, I'll write the code to be able to handle gravity and location updates and velocity. And I can add mass to all my items and then have that calculate momentum and handle collisions. I'm going to write all this physics engine code, or use an existing physics engine. But I'm going to have all this physics engine code. What I don't want to do is, okay, now I want to add grenades. Let me take my entire physics engine, copy it, paste it, and then replace my item type with grenades and be able to support that. Or somehow add to this physics engine the ability to handle grenades because I added this new type to my game. I'm not doing that. Like, nobody's going to do that. That's crazy. That's ridiculous. So the reason for polymorphism, what we want polymorphism to be able to do is we want to be able to use polymorphism to write methods to abstract types. This is what we want. I'm going to write one method here. Game item, or use item that takes a game item. Now, in my we'll get there. Okay, collapse my methods again. Stop doing that. There's got to be a setting somewhere that I can say stop doing that. Now, when I write my code to use these items, I'm writing one method. I want that's what I'm looking for, my main method. Let me get our main method on here. Oh, damn it. Player.use weapon 1. Player.use item. We'll get there. We'll get there. Let me do a little setup here. Health potion. Potion equals new health potion. And I already forgot what class we just created. Gold bars. And gold bars equals new gold bars. We'll say 1,000, and we'll put it at the origin. Now, player, instead of having a separate method for each of these, use item potion, use item bars. Why doesn't it like my potion? Tell me I got auto imported again. I did. So now I have one method that can be used with 3 different types. Instead of writing 3 separate methods for all of these, look at it, auto collapsing my methods again. Instead of writing 3 separate methods for my 3 separate types, I'm writing one method that can handle all 3 types, which completely eliminates the need for these methods. I have one method, even when I have hundreds of different game items that extend the game item class. I don't care. I have one method that works for all of them, even the ones that haven't even been dreamt up yet. This one use item method will work for every single one of them. So while you wouldn't do game item weapon 2 equals new weapon, you wouldn't do this all in one line, but you will have assignments like this. They'll just be across method calls. So we do have game item equals weapon 1, game item equals potion, game item equals bars, which are all their separate types, but the assignment is across parameters being assigned arguments. And this simplifies our player class by letting our player class write one method that works with everything that ever extends game item. Now inside this method we do have the downside of only being able to call game item methods, but that's acceptable. It's usually acceptable in our cases. If we can avoid reduplicating our code for every single thing that extends game item, and we lose a little functionality, the fact that I can't call get damage in this method or get increase or get monetary value, I'll make that sacrifice to be able to make this code much, much simpler, even though I'm restricted to just game item. Game item has the use method, which the use method can be specific. When I call use item on weapon, let's go back to the debugger and show that. When I call use item on my weapon, even though I'm bouncing around the code a bit, I'm calling use item on weapon 1. I get into the use item method, and item is a reference to an object of type weapon. So when I call the use method over here, I get into the weapon class. I'm in the weapon class calling its use method because that's the type of the item that was used. Item was of type weapon, even though it's stored in a variable type game item, I still get weapon specific behavior, and I can still access that damage variable, that damage instance variable, through the use method, which can be called through game item variables. And we get the damage set. Player's damage output is now 20. We can use that potion. And same thing, item.use, when item is of type health potion, we're still getting the health potion's use method because the object, the calling object, is of type health potion. So we look in the health potion class for the method that's being called, and we get our health potion specific stuff. I'm going to skip over all the getters and setters. We shouldn't heal the player at all because we're already max HP, so we don't actually have any effect here. And then when we use the gold bars, item is of type, a reference to an object of type gold bars. So even though the object type is game item, the object being referred to is still of type gold bars. So when we call use, we're going to get into the gold bars class, which did not override the use method. So when we continue our search in the super class, and we do actually get the game items use method that does nothing here in this exact instance. But one method to handle all of our game items forever. But wait, there's more. Oh my goodness, there's like 1 pixel where I can resize this. But there's more. So that's I mean, that alone is super powerful. We can write methods that work with abstract types, and anything that is that type, so anything that has that type as one of its super types somewhere in its inheritance tree, can you can call that method with those variables. I'm going to try real quick to change my settings on this because it's annoying the crap out of me. This will be my last try. Oh, we're actually, I feel like we're close too. It's not even, this doesn't have a Java thing. Oh man, even if I find it at this point, it wasn't worth it. Dang. Alright, sorry about that, but look, even maybe it would be worth it. Man, that's annoying. It wasn't doing this so aggressively in the oh, this is it. One-line methods. There we go. Okay. It wasn't doing it so aggressively in the other lecture or all semester. Okay. So it doesn't stop there. This is nice. This is very powerful, especially when we have large pieces of code like our physics engine, our game engine. We don't want to write new methods for every single type. Just code to the abstract type, I haven't introduced abstract yet. We're getting there. But code to the super type and then have it work there. But this also extends to data structures. So what happens when I want an inventory here? And I have public void pick up item, and I have to have weapon, and then I have private array list of weapons equals new array list this dot weapons dot add weapon, and then I get in cut and paste mode, pick up item, and I'm going to overload the method this time, so it'll be a little bit different. Pick up item health potion. This is actually allowed. Potion, change my variable name so to make sure it makes sense. Potion, and we can't add it to the same array list, so this array list needs to be duplicated. Health potion, potions, and you can see even just setting up the example is pretty annoying. You can see how tedious this gets. Gold bars, potions, pick up item, potion needs to be added to the potions. Gold bars, this is of type gold bar. And it's a lot of strain on my brain too. Like, I got a lot of little things that I have to pay attention to. I don't ever want to be in a situation like this when I'm coding, where I gotta make sure, I gotta double check, okay, health potion, potions, gold bars, gold bars, weapon, weapons, weapon. Okay, I think I got everything. I got my 3 array lists, and then I could start, instead of just using these items, what I want to do is pick these items up and add all these items to my inventory. So I want an inventory system, and I actually can overload this method, so I can have them all have the same name. I could have done this with the use item instead of use health potion, use weapon, use gold bars. I can have one use item method a name and then give it different parameter lists. And now this is an overloaded method, and the method that's going to be called will depend on the method, on the argument that you're given. So when I call pickup item with a weapon, I'm going to get the version that takes a weapon and add that to my weapons. When I call it with a potion, I'm going to get the version that takes a health potion. Java will look for a matching parameter list to match my argument list and call that version of the method. So adding the gold bar, I'm going to pick up a gold bar. And now I have a player with their 3 inventory array lists with the appropriate types. Hopefully at this point I'm solid enough. I don't have to tell you why this is horrible. Of course, you get to 100 different item types. This is just absolutely awful. What happens when you want a method that decides whether or not the inventory is full? You have to iterate through all of these array lists, and when we add our 4th item type, we have to modify that code. We have to add a new method. We have to make a lot of changes to the code to get that. Of course, we're not going to do any of this. Game item. So in addition to being able to store variables in store objects in variables of any of its supertypes, you can also put them in data structures of any of its supertypes. So now we want one inventory to rule them all. One inventory of type game item, and that inventory can store our objects of all these different types, as long as the type is of that type, of the type parameter for the data structure. This is a valid call. This is all valid code. We can add these items into that inventory. We can rerun our debugger to see this in action. I'm going to do step over this time, step over all the calls, but we can see that we have one data structure of type game item that can store weapons, health potions, and gold bars. So we can now mix in our data structures, we can mix our types, something we really took for granted in with Python. Python just lets you do that. Java, being strongly typed, doesn't. But now we finally can. We have one array list of game item for all of our inventory items, and we have weapons, health potions, gold bars, all mixed together in the same data structure. Isn't it amazing? Look at that. And we can simplify this further. We don't need 3 methods. We already saw that we can have method calls to the abstract type. Let's do game item. Item, I used the word abstract again. I didn't mean to. Item to the super type, and just have one pickup item method. So we can pick up items. As long as they extend game item, they can go in our inventory and they can use the same method. So all of that code is extremely simplified. We have one data structure, one method to pick up items, and we can add a few more methods here. Let's do use item at index. Say I want to use a specific item in my inventory. Now from the player's perspective, I would just like click on that inventory slot, but let's have that give us the index for that inventory item. And we want to use the item at that index. So we're going to do this dot inventory dot get index. And a few different ways we can do this, but I'm going to call my use item method this dot use item. Grab that item and use it. And there's a few problems with this method, the way it's written. Some things that don't necessarily jump out immediately. One, I went on a big sidetrack in the first lecture. I might do that again here, but I might not. But one big thing is this dot inventory. We want to make sure we remove that item from our inventory. Remove index, which will remove the value at that index. And also we want to do some type checking. Is this a valid index at all? So we don't know where this method is called from or how it's being called, or we don't know anything about it when we're writing this. Like, what's the actual use case of this? Is this only other developers calling this item? Can the end user give us an index? I don't know. But I want to be safe just in case. So let's check if index is less than 0, which would be an invalid index, or if index is greater than or equal to this.inventory.size. So if either of those are true, can't use item at index. Sure. And kind of a tips trick category thing is based on preference. I prefer to have my code indented as little as possible. So I actually want the code that does the work to be at this this indentation level, this top level of indentation, the indentation level of the method itself. Because what you would do normally, what you can do is else and put this code in an else block, because if I didn't hit my check, then I'm going to run the else block and that's where all my code goes. But since this is like a quick check, I'm going to check, and then if that check fails, I just want to get out of this method entirely. And it's kind of, I think it's kind of gross to have all of my logic inside an else block like this. So I'm going to get rid of that. And if this is true, so if this is an invalid index, what I can do is, this is a void return type method, but I can still use a return statement. I can just say return. And so if this is true, print some error to the screen, whatever we want to do to notify the user, like, hey, you can't do that, and then shut it down. So if I ever get beyond this conditional, I know that this was false and that I do have a valid index, but I can still hang out at the top level indentation. Now, some developers don't like this. Some developers would say, no, put that in an else block. So it is personal preference, but I just want to present this option to you of your, to add to your coding style if you choose. Or if you don't mind the indentation and you don't like the messing with control flow like this with a return, then that's perfectly fine too. You know what? I will go on the other tangent. I think I made all my points with polymorphism. We want the data structures that can store mixed types and methods that can take multiple different types based on inheritance. So let's go down this one tangent just a little bit here. So this, you'd be tempted to code this method like this, and this, there's nothing really wrong with this, the way it's written. We're going to use the item and then remove it from our inventory. The issue that we can have, and an alternate way to do this would be, let's see the alternate way to do it first. The alternate way would be to get the item from our inventory. It's kind of just something to think about. Remove it from our inventory. And then use the item. Pretty much the same thing. What this is avoiding, potentially, this will strongly depend on your actual implementation, the actual game you're building, the actual program where this code resides. It doesn't have to be a game either, but in general, whenever you're doing something with a value from a data structure and also removing that value from your data structure. So you're taking information from your data structure and also modifying the structure of that data structure. Whenever this is the case, you have to think of the order in where you should, I guess. Think of the order in which the events are going to occur, especially when you're writing concurrent code. So this, being a game, this would inherently be concurrent code, which means your code can be running multiple pieces of code simultaneously, possibly on different cores in your processor, in your CPU. So what the reason for that is you're going to have your game loop, which is going to be updating physics and graphics and just doing all the processing, all the stuff. And while that's happening, because that's always happening, while that's happening, you also have to listen to user inputs. For keyboard inputs, mouse clicks, mouse movements, you have to listen for all those user inputs. And you don't want to say, hey, sorry, user, I'm updating the physics right now. I can't, I'm not processing your mouse click. That mouse click has to be registered, or your game is unplayable if it keeps eating inputs. So your code naturally has to be concurrent. It has to be doing at least two things at once: updating the game, handling previous user inputs, and also listening to new user inputs. So what happens when you have this code and the item takes a while to use? Maybe the code for this item, somebody writes a game item that, for whatever reason, using the item it takes up a lot of processing power. It's a really complex item that has a huge effect on the game world. So that code, that use method for that game item, it takes a long time. Maybe it takes 2 frames, 2 updates of your game for that to run, which is an eternity basically. 2 frames. So there's 2 updates of your game where that item is being used. Now you have a 2-frame window where the player can start abusing the setup that you have. So they use the item, but while the item's being used for 2 frames, you have this very small window where that item that's being used is still in the user's inventory. And then they can start trying to exploit this and abuse this in different ways. They might have an item duplication glitch where they'll use the item and then immediately remove it from their inventory themselves, which will be removed using some other code. And then this line won't be able to remove that item. The inventory gets in a glitchy state. They might have a really obscure bug like that. But if we do it the other way, if we remove the item from our inventory, from the player's inventory, and then use it, now it doesn't really matter how long that use takes. That use can take a while. The player's not going to be able to abuse like an item being used, but also being in their inventory. They're not going to be able to mess around with that. And in general, this is a problem of concurrent reads and concurrent writes. When you have multiple pieces of code that are trying to modify the same data structure simultaneously, you can get really, really wild bugs whenever that's the case. So being very careful when you're modifying a data structure that might be modified by other code is or read by other code can create really, really interesting bugs. So being careful about that. This is one example of that. I would remove it from the player's inventory and then use it to avoid some obscure bugs. Which that one would be maybe an obscure bug. Nobody's probably going to just run into that one, especially if it is the 2 frames that I indicated. Maybe if they're mashing really fast. They're like, I really need to use this health potion, and they realize that it was used twice, and they got double the healing power out of it. You know, they might find that, but usually it's going to be people trying to intentionally break your game who would find that bug. And they'll exploit it to hell. Okay. Alright, I did go on the same sidetrack, which is it's a fun one. I like explaining that one. We picked up items. Let's use one of these. Player dot use item at index 0. So let's equip that weapon. And then player dot... Oh, I didn't write that method yet. Let's also use all items. So public void use all items, just to show that we can iterate over a data structure like this too. So we can say for game item in our inventory. So iterate over all of our inventory items, and this dot use item, which we'll call this use item method, which we'll call the items use method, which will use the item. So use all items. Let's get rid of this code. We don't need this anymore. I'll leave these two, even though we're not going to use them anymore. And now let's run the debugger again and see how this works in action. This in the slides and in the 8 a.m. I did this as a memory diagram. I'm going to skip the memory diagram this time, mostly because, well, 2 reasons. I can show you the same thing in the debugger, and most of you don't have to do another memory diagram again for 116. So if you got full credit on the midterm, you don't have to take the final. And the final is not going to have any polymorphism on it anyway. So those of you who have to take the final, there's not going to be any situation where I store an object of one type in a variable of a mismatching type. That I will never throw that at you on the final this summer. I'll do that in the spring and fall semesters when there's more time and I can do that. But this summer I decided we're just not putting that on a quiz. So there's no reason to do the memory diagram since you're never going to be assessed on this specifically, on polymorphism in a memory diagram. Same with graphs. I'm never going to have a graph memory diagram. So I'll probably skip the memory diagram on Thursday as well. And I want to show you more debugger stuff. The debugger is very, very, very useful. I want to show that off more. So the debugger, actually let me, speaking of showing off debugger stuff, let's show this off. Let me explain what I'm doing here. There's 6 buttons that I pretty much exclusively use when I'm running the debugger. Step over, step into, step out, rerun, resume, and stop. Stop is the simplest one. It just says, just I'm done using the debugger, stop. So I don't really have to explain that one much. So the 5 other ones I'll explain. Step into is probably my most often used one. It's going to advance one line of code and go into any method that's being called. And I know some of this is repetitive. I said some of this earlier in the semester, but it's worth repeating. And I forget which buttons I didn't explain, so I'll just explain them all. Step into is going to go into any new stack frame. So this is going to go into the pickup item call. I got pickup item stack frame added to the stack on top of my main stack frame, and I can see all the values in this stack frame. This was a reference to a player. Item was weapon 1, so game item equals weapon 1, which was this reference weapon 1 in my main stack frame. If I hop over to my main stack frame, weapon 1 is this at 532. So at 532 of type weapon, that's what item got. And then I'm going to then add it to the inventory. So this inventory has that at 532. I don't even know what I choked on there. Oh. So now my inventory has that weapon at 532. The next button I want to talk about is the step over. Step over will do basically the same thing as step into, except it won't go into any new stack frames. So that it'll run the next line of code in its entirety, including any stack frames that would have been called. So I'm going to skip over the pickup item stack frame. I'm going to say, look, I'm not debugging pickup item right now. I just explored it with adding weapon 1. I'm good with pickup item. I just want it to execute without showing me the stuff. So just skip over, and pickup item of bars 2. Let's just skip over both of those. The code still executed. So if I look at my player class, I can still make sure that those methods did what I wanted them to do. And it has weapon, health potion, gold bars. All these items were added to my inventory. But I didn't want to go through, the pickup item stack frame. It's just extra clicks. I didn't want to go through them all. Now with use item at index, this one I definitely want to get into. So I'm going to step into the use item at index. We haven't explored this one yet. And actually, I want to change this code. I forgot this same thing in the other lecture. I want to test this isn't really testing, it's a main method, but with the debugger. This would be in full tests. But let's test to see if our check to see if the index is valid, make sure this is working. So I'm going to check my endpoints here. -1 and 3, these should both be invalid. And since I changed the code, the debugger is not going to see that changed code. It's not going to run my changed code. So I do have to click our next button, rerun. That's going to start the debugger at the top and just go all the way through again, starting at the beginning of the program, but now with my updated code. And it's going to hit my breakpoint, and I don't really want to be at this breakpoint, and I can click step over a couple times. It's only a few clicks in this case. It's not that big of a deal. But instead, I want to show you another button. I'm going to set another breakpoint here at the next line that I'm interested in, and then click resume. What resume's going to do is resume running the program, just go at full speed, just ripping through it all until it hits another breakpoint. So it hit my next breakpoint. It executed all 3 of these pickup items. I can see that they're all in my inventory. So all this code did execute, but I skipped over all the details. I said, debugger, I'm not interested in those. I already debugged pickup items. I'm sure that's not where the bug is. All of these constructors too, superclass constructor calls and all that. I'm beyond all that stuff. So all this stuff I don't care about anymore. Just rip through it and stop when you get to the interesting part that I want to observe again. And in fact, I'm going to remove this breakpoint, so we're never going to stop at that part again. We're going to start looking at these use item at index methods. So with -1, index less than 1 is true, and we can see that the rest of this expression was short-circuited. Since the first value was true, this resulted true, and then it's or whatever. No matter what this would resolve to, true or anything is going to be true, so it doesn't even bother executing the right-hand side of this expression. It's just going to be true. It's going to get into my print line and then just return. And when a line is printed like this, when you're in the debugger, you can flip over to this console tab, and it's going to show you everything that's being printed to the screen, in addition to some debugger output. But it's going to show you everything that you're printing to the screen. So it's printed, can't use item at index -1. I'll flip back over to my debugger to see what's going on in memory. We hit the return statement, so that just exits the method, and we get to back into the main stack frame, which is going to put a use item at index frame on the stack. This time, both sides of this have to be evaluated, but the second one is going to be true. So we get into can't use item and return. We can check can't use item at index 3 was printed. And now using an item at index 0, our Boolean is false. So now we actually get into the core of our code, the actual logic of this method. We're going to get the inventory item at index 0, which is going to be this weapon. We're going to remove that item from our inventory, which is going to push everything up by an index. So when you removing the first value of an array, or an array list in this case, is very expensive because everything else has to be moved over, copied by one index. Here it's only 2 values, so whatever. But if this was a million things in this array list and I remove the first one, that's an expensive operation. That gets very slow. And we call use item. Now, item is of type game item, but that doesn't matter. That just depends. That just decides whether the item is called. Actually, let me get into the next method call. Game item. The variable is game item, which only decides if this is a valid method call. When we actually call the method, it depends on the type of the item itself. So item is a weapon. So we go into the weapon class, find the use method, and this is the method that's called. We're going to set the damage dealt for the player. And at this point, I want to show the last button, the step out. We're kind of deep into things here. We're a few stack frames deep out from what we're really what we're debugging. And we did get to where we wanted. We got the right method called. We're equipping this weapon and changing. The next thing that's going to happen is our damage dealt. Well, let's go one more. Damage dealt is going to be 20. But we have a whole bunch of frames on the stack. The next button is step out, which will resume execution until the current stack frame returns. So if we have all these frames on the stack, if I want to get back to the use method, I can just one click step out. That's going to bring me back to use. No matter where we are with use, step out is going to bring me back to use item, which all these methods are at the end of their execution anyway. So it's it would have the same effect if I click step into here. But this will run till the end of that method call. Like for example, if we're in use all items, this is about to do a whole bunch of stuff. If we do step out, we're going to go right back to the main stack frame. It executes until the current stack frame returns. But now I overshot what I want, so let me move my breakpoint to use all items and rerun this. So we can actually step through use all items. So let's step into use all items. The inventory only has 2 items in it now. Damage dealt should be 20 because we used the weapon. And now we have health potion and gold bars in our inventory. Gold bars still doesn't do anything. That's the next thing to do is circle back to that, but we haven't done it yet. So this isn't going to do, gold bars won't do anything yet, but that's fine. So we have item, which is a health potion. We're iterating over the health potion first. So when we use the health potion, we are in the health potion class and use that health potion method, which we're already max HP, so healing isn't going to do anything here. And I don't want to go into all these getters and setters, so I'm either going to click step over and skip over this whole line, which will bring me to the end of the method, or step out, which will just end the method right away. All the code does execute, but it doesn't show me the details. So that method ended. We go to the next iteration of the loop. Now we have the gold bars is the next iteration. We're going to use the gold bars, which isn't going to do anything because we never overrode the method. So we got the default method, which does nothing, which is a great segue into the next thing that I want to talk about. Let me just go one screen. So the use method, and this is, we're shifting into more inheritance topics here. When we covered inheritance week, if you've learned Java before and you did inheritance in Java before, you probably noticed something missing from the inheritance lecture, and that's abstract. The word abstract, implements, and interface. These three words were completely missing. So let's introduce those words. They belong in the inheritance, like they're more inheritance topics. They belong in that lecture, but that lecture is kind of stuffed, and the polymorphism lecture is kind of light. Like I'm done talking about polymorphism. That's all the things that I really needed to cover. I still got more stuff to say. We'll still do more stuff, but you have all the concept out there. I want to do more stuff to. I just want to do more stuff. There's more stuff I want to show you that I think will help on the homework. So we have room in this lecture to cover some more inheritance stuff. This isn't necessarily polymorphism stuff. And that's abstract methods and interfaces in abstract classes. So let's talk about what these things are. So the use method doesn't really have a good default behavior that I want to give it. So there's something else we can do. Instead of giving the use method a definition, what we can do is make this abstract. And it's not going to let me do this. We can make this abstract, which means this method doesn't have a definition. Now, once you have an abstract method like this, and the reason Java is going to get mad at me is what should happen when somebody calls this method. So what happens when we have a gold bar which doesn't override use, and somebody calls the use method on a gold bar, which looks to its superclass for the use definition, and there just is no definition here? What should happen? And there's some, like, you can speculate. This returns void, so I think a reasonable guess would just be doesn't do anything. But what happens when it returns int? What if I have this return an int? What should be returned? What happens if it should return a player object? What should be returned in those cases? The default values, like 0 or null or empty string? Like, what do we do? Well, I don't know. Java doesn't know. And what Java says is, we're just not going to let you do that. You can't call an abstract method. Not going to allow it because we don't want to answer the question of what should happen when an abstract method is called. So it just can't be called. And Java takes it a step further and says, well, you can't just not call that method. You can't even create an object of that type that contains that abstract method. So if you have any abstract methods in your class itself must be an abstract class. And that gets rid of my error down here. That class itself must be abstract. And one big thing to know about abstract classes is you cannot instantiate them. I cannot create a new game item, which is something we don't want to do anyway. But we get game item is abstract, cannot be instantiated. So you can't create an object of an abstract type. Now, we don't want to do this anyway, at least in this specific case, because what does it mean for a player to have a game item in their inventory? Like, it makes sense for them to have a weapon, gold bars, bow and arrow, grenades, diamonds. It makes sense to have those items. It doesn't make sense to have a generic abstract game item. It really is an abstract concept. It makes sense for it to be an abstract class and not let anybody create objects of this type. Now, we can't create objects of this type. Well, we can't create objects of this type because it's abstract, and it has to be abstract because it has at least one abstract method, and this is Java's protection against ever being able to call this use method with no definition. So instead, let's get rid of this whole main method. So instead, if you extend an abstract class that has any abstract methods, you have an obligation to override any abstract methods. the inheriting classes absolutely must override that abstract method. Any abstract methods that they inherit, they have to provide definitions, with one exception, like weapon also overrides that use method, so we're good there. But gold bars does not. So we get an error here. It's going to say you have to implement that use method because it's abstract. The only exception to this is if the inheriting class itself is abstract. Of course, I spelled it wrong. If the inheriting class itself is abstract, well, that's fine. But now we can't instantiate gold bars, and we're going to have errors over here when we try to say new gold bars. Can't instantiate an abstract class. That's not allowed. And gold bars has an abstract method with no implementation. We don't want any of that. So we finally want to circle back to this and override that missing method. Now we're forced to override it because it's abstract, but we do want to override it anyway. Public void use takes a player, and we don't really have anything. Like, we only have these 3 values, so there's really not much. Let's say if you get rich, you can increase your max HP, set max HP. I don't know, using gold bars increases your max HP by its monetary value. That doesn't make sense. Let me just print something to the screen. Nothing else is really going to make sense. Let's print out I'm rich. So now that gets rid of our errors. We implemented the abstract method. So now use does have a definition. It's allowed to be called, and our class does not have to be abstract anymore. And otherwise, everything else works the same way it always has. I don't even print anything to the screen except I'm rich and the index out of bounds. But all the code works exactly the same way it did before. We just have an abstract class now. And in fact, even if you don't have any abstract methods, like now I don't have any abstract methods, the code's back to what it used to be before, I still might want to make this class abstract, just because it doesn't make sense for somebody to create a new game item. I still might make this abstract just to prevent anybody from creating a new game item. Like I just want to shut off this constructor, basically, unless it's a super constructor call. Basically just want to shut that off. So it can still be abstract even without any abstract methods if that's what you want to do, if you want to restrict object creation. Because sometimes there's no need for any abstract methods, because why would you need an abstract method? Why would you ever do this? Why not always give a default behavior? And the answer is sometimes the default behavior doesn't make sense. Like having the use method with a default behavior of doing nothing didn't really make sense. If I make it abstract, I will never forget to override it. Like each item should override the use method and do whatever its specific thing it does in your game world. Like it should be overridden in this case, for this specific example. The use method should be overridden. So it makes sense for it to be abstract, to force everybody, hey, if you're extending game item, implement your use method to decide what you're going to do. If you're not implementing the use method, like, what are you even doing? Like, why are you creating a new game item class to begin with? You can probably reuse another class or some other code. So it doesn't really make sense to have a default behavior here. And especially in our next example, the comparator class. This one doesn't make sense at all. In Inheritance Week, we intentionally don't talk about abstract classes or interfaces, so we couldn't have any abstract methods, which means we had to give some default behavior to the compare method, and we just have it return false. Now, we don't want any comparator to just return false. Like, we don't want this to be the default behavior of the compare method. We just added this because we had to have something because we didn't have abstract methods. And then in decreasing, we just have to be very careful with the way we override things. We have to I like to have in the annotation to double check us, but we just have to have everything just right here, because if we have no annotation, first of all, and then like a misspelling here, Now when we try to use this comparator, it just returns false. We can run our insertion sort code 165. Let's run this and see what it sorts. It's just going to return false all the time. And we get 561. Like, we're not going to get our sorted order, and we're going to be trying to debug this and figure out what's going on. And actually, this one isn't too hard to debug. Let's set our breakpoint, run our debugger, skip over the constructor, mostly just because I know that's not where the bug's going to be. Go into the sort method. And then by the time we get to the compare call, like you might go through that slower. I know where the bug is, so I can go right to it. But you might step through everything, double check all your values as your code's running, make sure everything makes sense. But when you get to the compare method, you're going to get to this compare method that just returns false. And you're going to go, oh shit, what happened here? And then, you know, hopefully arrive to the right solution, go to increasing, realize that you never overrode anything because you misspelled it, and then fix your bug based on the symptoms that you saw in the debugger. But there's a better way. We just make this abstract. So the real power of abstract methods, the real use case for abstract methods is when you want every class that inherits your class to have a specific method, but you don't have any default behavior that you would like them all to have. So we make it abstract to say everything that implements me, everything that extends me, everything that inherits from me will have this method in game item. Everything that is a game item will have a use method, which is important to our player class because the player class needs to call use on objects of type game item. So we want to make sure every game item has a use method, but we don't have any specific default behavior to give them. So it doesn't make sense to give this an implementation, but we need it to exist because when we start using polymorphism, we want to make sure that that use method does exist, even though we're not going to know what it's going to do because it depends on the actual type of the object. But everything that extends game item does have to have the method so we can call it through objects of type game item. So we're allowed to do that. So that's why we would have abstract methods. So in our comparator, we're going to make compare abstract, which means this has to be an abstract class. But we can take this a step further too. If an abstract class has nothing but abstract methods, we can take this a step further and call this an interface. Ta-da! An interface. An interface is similar to an abstract class, except it can only have abstract methods. That's all it can have. And those methods have to be public. So I have public and abstract are grayed out here. Modifier public is redundant for interface members. Modifier abstract is redundant for interface members. I can delete both of these, and this is still a public abstract method. If I just do Boolean compare, because it has to be. An interface can only have public abstract methods, so of course it's a public abstract method. I don't have to say public abstract. It's redundant to add those words. And there are some exceptions to this. Interfaces, I say only abstract methods. So they can't have constructors, they can't have instance variables, they can't have methods that are not abstract, any method that's not abstract. None of those things can exist in an interface. The only exception is they can have static variables and static methods. And there is one exception, a newish feature in Java that they can use the keyword default and have default implementations for their methods. But we're not diving into that. But if you do have an interface and you do something like int x equals 7, like that looks like an interface with an instance variable. So it will look like you can have instance variables, but if we do the same thing we did on the method and we start adding in our modifiers and it says public, I type public and it says that's redundant. Of course it's public. Of course it's final. Of course it's static, because it has to be. So you can have, and since it is static, or since it is final, it should be capitalized. So we can have variables in our interfaces, and they'll look like instance variables, but they're actually public final static variables. So they're static constants that belong to the class itself. So I can do comparator.x. It gives me an error because it's not an expression. We can do comparator.x, but we access that through the I can't even comment that out. Well, I have to do this first. When we don't extend interfaces, we implement them. I didn't want to say that yet, but I have to get this code to compile. And we print out 7 to the screen. So this works, but it's a static constant, and the main method is static as well. So static members, static variables, static methods, those are all allowed, but they belong to the class themselves. Okay, so let's get rid of all that and then get to what I want to say here. I had to spoil that one, but implement interfaces, you don't extend interfaces. And the reason for this, the reason why to use an interface at all, because why not just have an abstract class that has nothing but abstract methods, is that you can only extend one. So let me not do this in int increasing. Let me do it in gold bars. You can only extend one class. I can't extend multiple classes. Like I can't extend game item and object. Like this isn't going to work for me. Cannot extend multiple classes is the error. Very clear error. But I can implement as many interfaces as I'd like. So if I want to implement, I want to make my gold bar a comparator of integers, which I don't know why I would want to do that, but I can. I'm allowed to. And I want to implement the serializable interface. And how about comparable? I want to be able to compare gold bars with other gold bars. I can do that. Now I have to implement all the abstract methods that I'm missing. So let me implement those, compare to and compare the abstract methods that I have. Nothing comes from serializable, but comparable. I have to be able to compare it to another gold bar. And compare, this is the one that we get from our comparator. So we have to implement all those abstract methods, but the point is we can implement as many interfaces as we want. We can't do that with abstract classes or concrete classes. Concrete classes are any class that's not abstract. Because these methods can have definitions. So game item has a method named move, which has a definition. Now what if I want to also extend another class which also has a method named move that takes 2 doubles and returns void, but does something else? It doesn't do the same thing. Now gold bars would implement both of those inherit both of those move methods. And when I call move on an object of type gold bar, what should happen? I don't know. Java says, whoa, that's so scary. We're not even going to let you possibly ever even think about getting to that point where you implement 2 definitions for the same method. So Java just takes a really big sledgehammer to the problem and say, well, you just can't extend multiple classes. This is called the diamond of death problem, where you get 2 different definitions. Java just says, no, not allowed. We're never even going to let you do the thing that could possibly ever come up with that scenario. It's not going to happen. Other languages like C++ will let you do that. They'll happily let you just get yourself in trouble. And the way they answer the question is just, I don't know, you'll get one of them. You're not going to know which one's going to be called, and you're going to have a really obscure bug. But yeah, one of them will be called. We'll just pick one. It'll be based on which compiler you used. It can be different based on different compilers. It could be different on Windows versus Mac. It can depend on a lot of things, but you'll get one of them. Who knows which one? Now with interfaces, you don't have the same problem because there are no definitions. So if comparator and comparable both had the same abstract method that you inherited, that's no big deal. Like from comparator, you get the obligation to implement that method, and then comparable says, I also want you to implement that method. Well, great. I was already going to implement it. I can implement the method once and satisfy both interfaces. There's no conflict of which definition is going to be called. There's still only going to be one definition. I just satisfied multiple interfaces with the same implementation. And that's perfectly fine. So that's why we're allowed to implement as many interfaces as we want. So if your class can be an interface, it's usually better to make it an interface just so you have that option of implementing the interface and also extending an abstract class. Keeps your options open. Implement, I did that, and then to circle back way back a while ago, we have insertion sort, which takes a comparator in its constructor and stores a comparator in an instance variable. And way back in inheritance and with BSTs, I said, look, we're going to create an insertion sort, we're going to create a BST, and we're going to throw it this int increasing. And we have comparator of t, which in this case is going to be integer. Comparator of integer, comparator equals new int increasing. And the types don't match. Comparator of integer and int increasing, the types don't match. And at the time I was just like, don't worry about it, it works. It's something called polymorphism and it's super cool. It's going to be great when we get there. And this is allowed. Now we can actually understand why it's allowed, because int increasing implements comparator of integer, and implements for polymorphism purposes works the same way as extends. If you implement an interface, an int increasing is a comparator of integer and can be stored in variables of type comparator of integer. So when this is comparator of integer, comparator equals new int increasing, that's fine because int increasing is a comparator of integer, and that's why this is allowed. It's because of polymorphism, because of the is-a relationship, because int increasing implements or extends from the comparator interface, which implements, in this case, the comparator interface. So the assignment's allowed. Then we didn't break anything. We should get 156. Kind of the end of my scheduled content and nobody has asked a single question. Can I assume that y'all just know exactly what you're doing? I'm tempted to end lecture early. I don't have any, I can breathe a sigh of relief. I got everything through that I wanted to. Oh, I'll talk about task 7 a little bit more. That's what I wanted to do. But ideally there are questions, because I don't want to just make stuff up and ramble on about whatever I want to talk about. Yeah, we refactored this. We did the debugger. Weapon class. We did the debugger to go through this. Yeah, that's what I want to show. We did in the slides. If you look through the slides, there's a usable interface that I used to show that you can extend and also implement. I decided to explain that a little bit differently here, but I got the same topic down. Let's get rid of this stuff. So yeah, let's talk about test 7, and hopefully you'll have some questions for me. Or maybe I will just ramble on. I don't like ending early, but maybe I will. Or I'll just ramble on until 1:30. So your populate library method and your media library class, let me start with the media library class, you have to handle songs and movies. They both extend rateable. So everything today, think rateable is your game item, song is your weapon, and movie is your health potion. Just that's the one-to-one correlation here. So media library, you need to store multiple movies and songs all together. So you should be thinking the media library class should have an instance variable that's going to be a data structure to store all of your ratables. And if it's a data structure of ratables, then it can store both movies and songs. You can mix movies and songs in that single data structure, which is neat. I don't know. I get excited for it. I don't know about y'all, but we could store them in the same data structure. Coming from Python, it's like, yeah, big deal. We could do that from day one of 115. But being in a strongly typed language and being able to do the same thing is pretty cool. So populate library is going to read those 3 files, get all your movies and movie and song objects created by the methods that you wrote from task 6, and stuff all those movies and songs into that data structure of ratables to get them all in the same data structure. And then when top K ratables is called, everything's in the world of ratables at this point. You can create a comparator of ratables, use whatever sorting method you want to use to be able to sort these things, and then get the top K values out of that. And then there's a few edge cases, like if I ask for the top 100 and you only have 3 songs and movies, like combined total, you're only going to return those 3. And then if there's 100 of them and you ask for a top 10 list, it should just be the top 10. Don't return all 100. So aside from those edge cases, you're sorting and grabbing the top K out of that and returning that as an array list, with the number 1 thing, the highest Bayesian average rating, being at index 0. Okay, no questions at all, and I'm not just gonna ramble. I feel like I'm talking to myself here. There's only one thing in chat over the entire 2 hours and 6 minutes. So if y'all have no questions, I'm gonna take a quick break and then go to office hours. And if you have questions, I'll see you there. If I don't see you in office hours, I'll see you on Thursday for the last lecture of the summer on graphs. I'm going to be talking graphs. All right, so see you then. Take care.